Laws of logarithms. There's laws of logarithms just like there's laws with indices because, of course, as we've discussed, a logarithm is just an index. There are various laws of logarithms and, as mentioned, unsurprisingly, they are all derived from properties of indices with which we are familiar. Note, in all of the expressions below, a, x and y are positive and a is not equal to 1. Law 1 says that, note that we're working to the same base all the way through, a base a, that log of m times n is equal to log of m plus log of n. And you'll be expected to apply this in both directions. In other words, take an expression like this and change it into this one, or take an expression like this and separate it. This first one, I'm actually going to derive. You probably won't be asked to do this. So what I'm going to do is let x be equal to log of m and y be equal to log of n, note to the same base. Using the equivalence of log and index statements, I can then say that m is equal to a to the power x and n is equal to a to the power y. So m times n is a to the x times a to the y, which means m times n is a to the x plus y using the appropriate index law. Using the equivalence of log and index statements in the other direction, we can then say that log to the base a of m times n is x plus y. But from above, x was log m and y was log n, and therefore log mn is log m plus log n, provided that the bases are the same all the way through. Law 2 is a similar one, but instead of multiplying m and n here, they're divided, and there's a subtraction in the middle there. This one is easily derived from Law 1 by using the same approach and the fact that 1 over n is n to the negative 1. It is most easily derived using Law 3 below, but we're not actually going to do the derivation of any of the laws other than Law 1. Law 3 says that log to the base a of m to the power k is equal to k log to the base a of m. In other words, a power here can slide down in front of the log. This is a very useful law. This law is just Law 1 applied repeatedly with m equal to n. And just to show that, if we have log of m times m, that's log m plus log m, which means that log of m squared is 2 log m. And we just repeat this argument for m cubed, m to the 4, etc. Induction, at least for positive powers. Law 4 states that log to the power a of a is equal to 1. Now that makes sense if you think about it in exponential form. A to the power 1 is a. And I've said that here. This one is really obvious if we convert to index form. Law 5 is log to the base a of 1 is equal to 0. And again, this one is obvious because we know that a to the power 0 is equal to 1. A useful identity, which is derived from Law 3, is that log to the base a of 1 over b is equal to negative log to the base a of b. It's this very identity that prompted me to write above that law 2 is easily derived once you have law 3. And this is not circular because all you need to derive law 3 is law 1.